In this video, we're going to discuss discrete probabilities. Recall from the beginning of the semester and everything that we began discussing about different types of variables and how they could be either categorical, which is qualitative variables, or they could be quantitative. If they were quantitative, they could either be discrete or continuous. In this video, we're looking at discrete variables. Discrete, again, recall that those are variables that can be counted. Number of people, number of pencils. They're counted in whole numbers. Things of that nature. These are discrete. Random variables are variables whose values are determined by chance. We've looked at many of these, such as looking at our probabilities, things like that. It's not a controlled, it's something that we have no control over. It's just completely random. So a discrete probability distribution is a distribution of values a random variable can assume and their corresponding probabilities. All it is making a table of those discrete values and what their probabilities are. Okay, remember back when we were talking about probabilities, the rolling of a dice. You have the possibilities of getting a 1, 2, 3, 4, 5, or 6. Those are discrete numbers. Their probability all happens to be the exact same thing, which is 1/6, 1 out of 6. So they all have the same probability. And we could make a table of that where it would look like the number on the die is our x, and then the probability of getting that number, which is p of x. So the numbers on our die are 1, 2, 3, 4, 5, and 6. Well, the probability of getting each one of those is 1 out of 6. So I've given the discrete numbers, the possible outcomes, and each of their probabilities. So I have just made this is a discrete probability distribution. It's as simple as this. The x value right here is the possible values that our outcome can take on. Let's look at another example to illustrate this. The probabilities that a customer will rent 0, 1, 2, 3, or 4 DVDs on a single visit to a rental store are 15 hundredths, 25 hundredths, 30 hundredths, 25 hundredths, and 5 hundredths respectively. What that means is that the probability that a person will rent 0 is going to be 15 hundredths. Probability that a person will rent 1 video is going to be 25 hundredths. Respectively just means in the same order. We want to construct a probability distribution for the data. Now I've already started the table down here. The number of DVDs rented, that's going to be our x value. It's a discrete number. And then we have the probability, our p of x, here. And so what I'm going to do is I'm going to fill in this table with my possible number of DVDs rented, which is 0, 1, 2, 3, and 4. And then I'll fill in each of their probabilities. So 15 hundredths, 25 hundredths, 30 hundredths or 3/10, 25 hundredths, and 5 hundredths. And we have completed our probability distribution. When it's asking for a probability distribution, It's just meaning make a table of it with the possible outcomes and the probabilities that are for those outcomes. There are some requirements for a probability distribution. One thing is to remember that the sum of the probabilities of all events must equal 1. Now if we go back over here, if I add all of these up, they should equal 1. So if I come down here and say that 15 plus 25 is going to be 0.4, and then I add that to 3/10, that's going to be 7/10. Add that to 25 hundredths, that will be 0.95, and then add that to 0.05, it adds up to 1 whole. So it's all added up to 1 whole. That satisfies our first requirement of a probability distribution. The second requirement is that the probabilities must be between 0 and 1. Recall back when we discussed probabilities themselves. Probabilities have to be between 0 and 1. They can't be negative and they can't be greater than 1. So we're still looking at those same requirements. So I can't have a negative number, I can't have 4.3, I can't have 1.7, anything like that. They have to be between 0 and 1. Okay? Once we've made the table, we can graph these just like we do for a histogram. The values will go along the x-axis and the probabilities will go along the y-axis. So in other words, we will have our x values down here and our probabilities of x along the y-axis, along our vertical axis. And we draw a histogram like with them. Okay? So let's look at this example. We're going to construct a graph for the probability distribution of the number of DVDs rented using the same table that we had before. I've already placed the table, just copied it over. So a person renting 0, 1, 2, 3, or 4. So I'm going to come down here and put my x values along the horizontal axis. These are the number of DVDs rented. So number of DVDs. Remember, I always want to label my axes according to my problem. My vertical axis is always going to be the probability of x. Okay? I'm starting at 0.05 and going all the way up to 3/10. So if I say 0.05, here's 1/10, here's 15 hundredths, here's 2/10, here's 25 hundredths, here's 3/10, and just in case, there's 35 hundredths. And I'm going to draw this. So for 0 DVDs rented, we had that was 15 hundredths. So it's about right here. And then draw down. Okay. And I can shade that in a little bit. I'm going to do the same thing for 1 DVD, that is 25. And then come down. And I can shade that in. 2 DVDs was 3/10, so I'm going to go up a little bit further. And then go across. And come down. Ooh. Thankfully mine straightens up a little bit since I don't have a ruler on here. Then 3 DVDs comes back down to 25 hundredths. And shade that in. 4 DVDs is down here at 500ths. So we're way down here. Oop. And so we're going to shade this in. And we have made our graph for this probability distribution. Again, we just make it like a normal histogram. Make sure that your discrete values down here are in order from least to greatest, and your probabilities are evenly spaced from least to greatest. We always want those items to be taken into account. Otherwise, you don't have a true representation of the data. If you have questions when you're practicing these, please let me know.